Hello and welcome to another video lecture from Mr. Watkins. This video lecture is about data and graphing, specifically what graph to use with the data that you obtain in a lab. So let's get started here. My paper that I've placed here is landscape, so it's lengthwise from left to right as opposed to top to bottom, and I'll be placing a flow chart on here, so just follow along as we go. Now right here in the center, when you run a lab, you're going to get some data. And that data is going to be one of two types. It's going to either be qualitative or it's going to be quantitative. So there's my qualitative and here's my quantitative. Okay? Qualitative would be things that have a value that is, in a sense, abstract. It's a value like good or bad or tall or short. So that's what I mean by value as opposed to a numerical value, which the quantitative data tends to be, or is, it's got the quantitative value. Now on the qualitative value, we typically don't graph this type of data. We may graph it if we are lumping things in, say, a frequency distribution, but you will not really see that very often. In quantitative, there's really two types of data that we're going to deal with, and that data could be discrete or it could be continuous. So let's take discrete first. Discrete data is data that you can count. It fits into a very specific narrow range, such as people who are right-handed, left-handed, or ambidextrous. There's really only three categories for that. You don't have a right-handed and a half person. So discrete, typically I tell students that you just count to get your discrete data. So you have a number, but you've counted to get that type of data. And with discrete data, we use two types of graphs. Basically, we use a circle graph. It's also sometimes called a pie chart. And we use these two when we want to compare a part of the data to the whole data set. So like what percentage of flowers are red, or what percentage of, well, just thinking the elections coming up, what percentage of the House of Representatives is Republican, what percentage is Democratic. Now, if you want to compare percentage of Republican to Democratic, in other words, you're going to compare two categories to each other and not necessarily to the whole, that is a different type of graph. And that type of graph is a bar graph. Now, for pre-AP and for my class here, the bar graph is going to be something that you might feel a little restricted because there's been some double bar graphs that you probably have done and a few other things. But what we're talking about here and what I want you to do in lab is to make your bar graph so that the bars do not touch, because this is discrete data. So in this case, we would have maybe the number of, or the percentage of males and the number or percentage of females in a particular class. There's no male and a half or female and a half. Very discrete, in other words, in a very specific category, these bars do not touch. And here's when you're wanting to compare each part to each other. Okay, now let's move over to the continuous data here, and I'm going to move the page a little bit so you can kind of see a little better. Continuous data is data that falls over a range, and that range, or that category would be a better word here, that category would be something that would depend upon how well or how accurate your measurement device is. So in a classroom, we could measure the heights of the individuals in the classroom, and we would have maybe someone who's 4 feet 9 inches, and then maybe if we had a little better measurement device, we'd be 4 feet 9 and a quarter inches, and we might have someone who's 4 feet 9 and 1/3 inches. And so this type of data is data that we take usually as a measurement. So I'm going to write measurement here. And that measurement may depend upon how accurate or how precise the measurement tool is that we're using. So we really do a lot more continuous data as compared to discrete data. Now with continuous data, there's really three types of graphs that you'll see here in biology. The first type of graph you're very familiar with, and it's a line graph. Now a line graph always looks at trend. Line graph will always look at trend. What is the trend? In other words, how does y change when we change a unit of x? Now, a lot of times I get students that come in and they say, oh, well, that means it has to do with time. Not necessarily. A great example for biology is this. We are taking a measurement of how fast an enzyme can work. Well, let's change the temperature of that enzyme and see how fast it can work. Well, temperature is our independent variable. It's going to go on our x-axis, and how quickly the time that it takes for it to work is going to go on the y-axis. So again, line graph is a trend. And on your line graphs, so let's say you have a line graph that does something like this. On these line graphs, you definitely want to find a way to make a best fit line, or a line of best fit, and calculate the slope of that best fit line. Now the reason why we do that is if you look at the graph wasn't very linear. In the sense of being a straight line, it was a little wavy. And so when we calculate the slope of the best fit line, we're actually looking at the rate. And sometimes you may have to do that. A second type of graph for continuous data would be a scatter plot. Now a scatter plot we do use, and we use that when we want to determine what is the relationship between two independent variables, between two variables that we believe are certainly related, and you have all this data points. It may be kind of hard to see, so I'll darken them in here. You have these data points, and when you step back and you look at it, it sure looks like all these data points are pointing in a direction here that's positive. And again, if you use a scatter plot, you have to get a best fit line. There just isn't a choice. You've got to do this. And that best fit line, again, we want to calculate the slope of that because remember, that's going to equal rate. Now the third type of graph, I'm just introducing this to you. Chances are you will not see this type of graph as we go through, but it is something that you will see on IB and AP test. And so in addition to the scatter plot, we have what's called a histogram. Now a histogram compares continuous data. And the thing about a histogram is that you're going to get your data, you're going to rank your data like from smallest to largest, and then you're going to find natural breaks in that data. So let's say we're looking at the measurement of height. So maybe we'll measure all the individuals, but we're going to group the number of individuals that are 4 feet to 4 feet 6 inches. And however many we have how many of those individuals, that frequency is going to go on our Y. And our X is going to have a bar that's 4 to 4 feet 6 inches. And then touching it, we'll have another bar that's 4 feet 6 inches to say 5 feet, and we'll count the number of individuals. So a histogram, the bars touch because you're putting them into categories even though they're continuous, and we are comparing that continuous data. Now here's the thing. We do this a lot, especially in ecology and some other areas. That's where you're going to see it the most. But be careful here because your histogram and your bar graph are very similar. If it's supposed to be a bar graph, but you put the bars to touch, you still will get that wrong because you're now saying that you have continuous data and not discrete data. Use this flow chart as you go through this year, even through next year, because it works 90 to 95% of the time. You know what the data you have is. You know it's probably going to be quantitative. You just have to figure out if you're counting or if it's measured, and then you can figure out which graph that you need to use. There really isn't any excuse for missing it. This thing works every time. I hope you enjoyed this lecture. See you in class.